Hi, Assalamualaikum. We are from United Times Near Berhad, which is from Group 12. My name is Siti Fatiha binti Muhammad Ihsan, Y93844. So, our main objective is to produce methanol from 35 million metric ton per year of carbon dioxide and to calculate the amount of energy and heat needed throughout the power plant. This is our raw material, which is flue gas, MEA solvent, known as monoethanol amine, limestone, ammonia, and water. For flue gas, this is our main production of methanol. Is from carbon dioxide that captured from coal-fired flue gas. The flue gas is obtained from a company which involved in the combustion of coal. 35 million metric ton per year of carbon dioxide is fit. For MEA solvent, it is used to absorb carbon dioxide from flue gas at absorber system. Limestone is react with flue gas in order to remove sulfur dioxide. Ammonia used to remove nitrogen dioxide in flue gas, and water used in electrolysis process to produce hydrogen gas. So this is overall process. Start from flue gas desulfurization, selective catalytic reduction, absorber, stripper, mixer, fixed bed reactor, knockout drum, flash drum, and with distillation column. So this is the process description. For flue gas desulfurization is to remove sulfur dioxide from the flue gas by using calcium hydroxide, and selectivity catalytic reduction to remove nitrogen dioxide from flue gas by using ammonia. Absorber to absorb carbon dioxide from flue gas with help of MEA solvent, which is monoethanol amine as catalyst. Stripper separate more water from the carbon dioxide, and mixer to mix carbon dioxide and hydrogen before the reaction in fixed reactor. Fixed bed reactor is to produce the production of methanol from carbon dioxide hydrogenation. Knockout drum separate liquid and gases after the reaction in fixed bed reactor. Flash drum separate liquid and gases. Distillation column to separate water from methanol and to purify the methanol production. And the last one is electrolysis, which is to produce hydrogen gas from water electrolysis.
Assalamualaikum. My name is Wan Nazia Liana and my metric number is 192032. So I'm the one who did the energy balance for the flue gas desulfurization and selective catalytic reduction. So before the flue gas enter the flue gas desulfurization, we need to compress it because it is from 1 atm to 28 atm. So as we were told, we need to use the word shaft in these equations, and after I calculate it, I got the endothermic energy balance, which is positive. And after that, we proceed to the flue gas desulfurization, and it is a reactive unit system because it have the chemical equation. And when I calculate the energy balance, I need to use 25 Celsius and 1 atm because it is a reactive. And I got the total for the energy balance for this system, which is in the endothermic form because it is in the positive. And for the selective catalytic reduction, it also a reactive system because it have the reaction. So I still need to use 25 Celsius and 1 atm to calculate the energy balance. And it's same with the desulfurization, it is the endothermic reactions. So I got the positive numbers for energy. And between desulfurization and selective catalytic reduction, there is a PRV, which is pressure relief valve for reduce the pressure.
Okay, so between selective catalytic reduction and absorber, we use cooler to cool down the temperature from 370 degrees C to 51.1 degrees C, and the heat needed is negative 0.33053274 kilowatt, which is exothermic. Next, at absorber, there's no heat because the temperature is remain unchanged. So we move to stripper. The temperature is changed from 107 degrees C to 106.45 degrees C. So the energy needed is negative 0.346 kilowatt, which is almost zero, and in exothermic. Yeah, thank you.
Good morning, my name is Anbar Hassan. So the next reactor that we're going to see is mixer. The function of mixer is to mix carbon dioxide and hydrogen before it enters the reactor in order to produce methanol. So we come to know from the calculation that mixer is endothermic because we get the positive value of heat, that is 1.856 exponent to power of 7 kilojoule per second, and then the component will enter the compressor in order to reduce its pressure, at the same time reduce its in order to increase its temperature and also its pressure. So here at compressor, the pressure increased from 1 atm to 78 atm, and it prepare for the fixed bed reactor. And then at fixed bed reactor, the methanol synthesis occur. At the end of this, we will get the product methanol, carbon dioxide, water and hydrogen. Since this reactor is an adiabatic reactor, so there is no energy balance calculation.
Assalamualaikum. My name is Ainuna Soha bint Hasnain. So basically my part is electrolysis, which is the reactive point. So electrolysis is to produce hydrogens from water. So energy balance curve from this reactor is positive one, which means it is endothermic. So after that, the hydrogen will enter the feedstock reactor and mix. So before it enter the after enter the feedstock reactor, there are cooler there before enter the knockout drum, which is to lower the temperature from 284 to 75. So we got energy here is negative one, which means it is exothermic reaction. So it means it is release heat. So after that, it will enter the knockout drum with 75 degrees Celsius. So basically knockout drum is to separate the liquid and vapor. So here we got the energy balance is also negative one. It means that exothermic reactions and it is release heat. So after we enter the flash drum, it will go to the pressure relief valve to reduce the pressure, so that the flash drum can accept this pressure. So here the pressure relief valve is zero heat because basically it is no heat here. After after valve, it will enter the flash drum, which is flash drum is same as the knockup drum, which is it is to separate liquid and vapor. So here we got the heat is also negative, which means it is exothermic reactions, so it is release heat. That's all from my part. Thank you.
Next, in order to feed the distillation column, we have to increase the temperature by entering it into the heater 1, which will increase its temperature by 80, and then it will enter the distillation column. So in this distillation column, it will remove the water and the methanol in the vapor form, and the remaining water and methanol in the liquid form will be our product. So from the calculation, we came to know that the distillation column is endothermic because we got a positive value of Q.
Okay, so I will explain for the costing part, which is we should fill all this total capital cost, production rate, price, sales, operating costs, revenue, cash flow, and the cumulative cash flow. But before that, we have to calculate the capital cost. Capital costs include all the reactant needed during our process to produce the methanol. So we have spent almost 1 million for that. And next, we have to calculate the operating costs. Operating costs include the raw materials, and we use water, limestone, ammonia, MEA, and also zinc oxide. And the utilities is for the power use, with the current tariff is 0.337. And for the fixed cost, we take 20% from the capital cost. And this when we put in the box that we have made before this, for the capital cost, it is a negative value. And for the sales, when the sales is minus with the operating cost, we get the revenue, which is almost 2 trillion, and it's quite high because we doesn't buy the flue gas, and our price for methanol is 163,200 ringgit Malaysia. And for the raw materials, the ammonia and the zinc oxide is added for every 5 years. And this is the flow chart, which is the graph showing our cumulative cash flow and the number of years. So that's all from our groups, and thank you.
So as a conclusion, the total productions of methanol that produced by our company is 169,680,62.67 ton per year from the feed of 35 million metric ton of the carbon dioxide. And the price of the flue gas do not include in this process science, since we just strip the flue gas from the coal fire power plant. The flue gas analyzer is used to determine the compositions of the flue gas based on the composition that needed in our process. Okay, so that's all from us. Thank you.